Today we're going to be talking about building human consumable APIs for London's public transport data. To break the ice, I'm going to start by telling a joke. I can tell this is a bit of a tough crowd. So, how does an Austrian baker greet his customers? Gluten Tag. Oh, got a reaction from the room. Thank you. How does an Austrian baker with celiac disease greet his customers? Gluten-free Tag. No? Okay. It's really bad. It's really bad. I was supposed to do some interactivity as part of this talk. However, it has been cut for the sake of brevity. That being said, I do have some swag to give away. I'd like my glamorous assistant to bring it up now. Thank you very much. Included but not limited to Elizabeth Line plush. Thank you. So if you'd like to get some free stuff, please ask or please tell me any facts that you have. We've got some mugs as well to win. And we've also got a collection of 15 phenomenal enamel pin badges, if I can just open it up. There you go, look. 15 pin badges, all related to today's talk. So please, tell me a fact, get some free stuff. My name is Leo Rivera. That's me carrying transport posters out of the station. I did not steal them, they were given to me. First and foremost, I'm an avid transport nerd. I'm fascinated by the planning, the engineering, and the operations of how people get from point A to point B and how modern transportation networks function. You'll get a sense of that throughout this talk. This, in fact, is a video of me.
I like singing. I like dancing.
I like trains.
I like trains. Thank you. So, for my day job, I work as a software engineer at a company that does adverse media screening and watch list screening, and I also do innovation and outreach. I'm an innovation and outreach lead at my consultancy company, so I talk about, or I do talks like these, and also explore how we can use current and emerging technologies to make the world a better place. Before we dive into building an API with London's public transportation data, we first need to understand how it works. Transport for London is the body responsible for managing transport in London. Each service has its own logo, and that shows that it has a distinct identity while saying it's part of a bigger family of services. It's an integrated transport authority similar to the Wiener Linien, I'm so sorry for that, in Austria. And basically, TfL is responsible TfL is responsible for the day-to-day management of London's public transportation, but it also implements the Mayor of London's overall vision for the city. Public data forms a big part of that strategy. TfL is a really big organization, and it's responsible for several modes of transport, including, bear with me here, buses with 9,300 buses on 675 bus routes, calling it 50 stations and 19,000 bus stops. It's got a metro service called the London Underground with 11 lines, 272 stations and over 402 kilometres of track with 5 million daily passenger journeys. It's got an underground commuter rail service called the Elizabeth Line that has 70 trains which are 204.74 metres long and that carry 700,000 passengers a day at peak times. It's got an orbital railway made of 6 lines that go around the outskirts of London called the London Overground. It's got a tram service with 4 lines and 39 stations over 27 kilometres of track. It's got a computer-operated railway in East London called the Docklands Light Railway with 40 stations, and it's also got 12,000 bicycles for hire with 800 docking points as part of the Santander cycle service. But that's not all. It also shares responsibility for managing London's road network with London's councils and Highways England. It maintains over 6,000 sets of traffic lights, manages 8 piers on the Thames, builds and maintains cycle infrastructure, regulates taxi services and private hire operators, and of course, it operates a coach station. The point is, TfL is big. If you want to get something from point A to point B in London, then TfL will, at some point, be involved. Some of its services, like the London Underground, are operated directly by TfL, but others are operated by private companies which are awarded contracts. So, fun fact, the RATP Group, which is actually Paris's public transport operator, has contracts to operate some bus routes in London. It doesn't really make sense, but hey-ho. Regardless of who runs them, TfL still exercises tight control over the service levels and the timetables, and that's really important. This tight control basically allows TfL to present its services, which are operated by different companies, as part of a unified network with a singular ticketing system. Services can be timed to avoid waits when changing modes, and walking paths and biking facilities can encourage more people to incorporate active travel, so walking, wheeling, and cycling into their journeys. A passenger can use a joined-up series of modes to complete a journey. Now, the partnership between public transport authority and private operator is actually so ubiquitous and originated in London that it's called the London model, and other cities in the UK attempt to emulate that relationship. Being so big, Transport for London and its many service operators use different computer systems to manage their operations. In the past, data for each mode, so bus and metro and rail and light railway and tram, that data was available at different endpoints documented by PDFs which are hundreds of pages long. Accessing these disparate systems proved, frankly, a pain in the ass. However, in 2015, TfL created a unified API which brings together data from almost all of its services under one endpoint at api.tfl.gov.uk. So the computer systems track the trains, buses, and trams whizzing through London, making sure that vehicles don't crash into each other, generating predictions, and of course, communicating with the UK-wide train information database. The unified API is truly a masterpiece of engineering, bringing all of this data together in real time and serving it up to us. When you look for transport data for London through any third-party search service, including Google Search, Maps apps, and travel and journey planners, they use this unified API to access the latest data from TfL. Accessing this data while on the move, however, proves difficult. So making requests through these third-party apps can consume a lot of data and can be slow with the Wi-Fi and the mobile data speeds common in some of the network. One of the problems with existing services for accessing TfL is that some websites will make several small requests instead of one large request to take advantage of concurrency. We operate in a world where bandwidth is plentiful and where latency is low, and so multiple requests on that high bandwidth, low latency network connection allows resources to be fetched faster. However, when you're under the ground and on some parts of public transport, you're operating in the opposite context with low bandwidth and high latency. So multiple network requests on such a connection will make a website feel slower and substantially less interactive because you have a slower network connection, and in addition, that latency is multiplied across all of the connections that you open on that wire. Wi-Fi points do exist at some stations and some trains, but they can be slow to connect to and obviously unreliable. But what if we built an endpoint that allows us access to transport data with what little signal we do have underground? What if we made it small? What if we made it fast, flexible, and informative? And what if we made an API that's easily consumable by humans? Or a human consumable API. Yep, I came back to it. No more downloading HTML and JavaScript and CSS to download a website which then downloads the data that you need. That seems like an unnecessary middle step. No need to download an app in advance, and there's no need to make a bunch of web requests for type aheads and receiving a variety of results and whatnot. Simply a single HTTP request that tells you the status of a station or a bus route or a line. How hard can it be? Pretty fucking hard. Yes, so a couple of things got in my way while trying to produce this one API, or this human consumable API, using the TfL unified API. And I'd like to take you along this journey with me. Keeping on theme, I'd like to go to our first stop, which is bad documentation. Thank you, I'll be here all week. I live here now. This documentation is abysmal. This looks like a good Swagger UI portal, but it is not. First off, this page doesn't document all the APIs available. By the way, this is sort of where this talk goes off the rails. I'm going to start using red circles and pointing at things. It's going to get unhinged quickly. The try this endpoint button doesn't work. They don't use API keys anymore. And we don't even have a response schema. You give me a Swagger document and you document your APIs, but you don't tell me what I'm getting back from them. It's impossible to use. And so effectively, I have to guess what each item in the response schema means. And the reason this API is so bad is because it isn't even the right documentation despite being hosted on TfL's website. You have to go to a completely separate website that is api-portal.tfl.gov.uk. Despite the previous page being the one linked to whenever you register for a new application, that's a little bit confusing. I don't necessarily know how that works. At the top of the page, I do quite love that this specified API does not exist, despite having plenty of API document. Never mind. But even this page and this documentation fails at its job. If we look at this example endpoint, it gets the arrival predictions for all stops of a given mode. However, if we scroll down a little bit, we'll see a glaring problem. Can anyone see the problem with this page? I'll give you a couple of seconds. Somebody? Anybody? Nobody? When providing a prediction from this endpoint, this schema gives us no guarantee that any data will be available. I'm sorry, you're going to give me a prediction, but you're telling me you cannot guarantee where the train is going. That's insane. It makes this API more than useless. And so, effectively, this bad documentation makes it so much more difficult to do anything cool with the API, because instead of spending time making something cool, I'm wasting time trying to crack how it works, and in addition to that, trying to figure out, or coding defensively, to actually stop one bad response breaking my entire application. There are also no endpoints which return dummy data, meaning if you want to check whether a disruption on the network, or if you want to see the response type for a disruption on the network or the shape that will take, and the information provided, and the format of that, you have to wait for a disruption to take place. So if I want to put a disruption in my application, I have to crash a bus stroke train stroke tram. I'll be right back. The lack of dummy data that we have makes it incredibly difficult for us to test our own applications, as we can't write test cases for data that we don't have. On top of this documentation doesn't communicate the mental models necessary to understand the API and how to use it. The applications that we build as engineers don't know about and frankly don't really care about the real world. As engineers, we abstract the big, wide and scary world away and we tell our machines exactly what they need to know. And us not communicating the assumptions that we make while building those API, or while building those programs, forgive me, and the constructs that we program into our computers, if we don't communicate those clearly, then that presents a massive barrier to those who actually want to understand or work and do something with it. For example, in some parts of the TfL API, the model of a train station includes some unique identifiers, including the name of the station, the latitude and longitude, the fare zone, and the modes which serve the station. However, the document doesn't explain why the data is structured the way it is. And so we don't know the limitations of the data we're receiving or the reasoning behind including or excluding certain data. And so it makes it difficult to know what endpoints we can use or even whether the data is available at all. Working around that bad documentation, we come to our second stop. Constructing APIs for things which exist in the digital world is difficult. Constructing APIs for physical and tangible concepts is borderline impossible. Dealing with all the intricacies and complexities of the edge cases of physical spaces is a pain. You can often engineer that away in a system that focuses purely on the digital. However, when building systems that work with the real world, you have to account for them. People who are smart and work in particular industries often concoct technical standards that allow for collaboration, and public transport is no different. There is a standardized dataset in the UK called the National Public Transit Access Nodes, or NAPTAN for short, very catchy, which is just a big list of any and all transport points. So we're talking bus, rail, tram, metro, underground, and ferry, which makes sense, but also air stops. You can have domestic flights and even airports are in that database, which seems a bit weird, but go on. However, London and transport in London has a very long history. London, in fact, doesn't even have a date which it was established. We simply believe that London and the City of London existed from time immemorial. And the first underground line, which was the Metropolitan line, finished construction in 1863. Initially, these TfL lines were operated by different companies and they had different identities, and as time progressed, business units and transport authorities acted independently of one another through mergers and abolitions, meaning they weren't able to make coordinated decisions when it came to naming things and assigning IDs. And as you can imagine, it has been a pain to slog through. For example, take St. Pancras Station. You can refer to it by the name, by the station code, which is used when booking tickets. You can refer to it by the NAPTAN ID, of which a station could have several because NAPTAN IDs exist for doors and platforms. You could refer to it by the WGS84 coordinates, so latitude and longitude. You could refer to it by the UK postcode, or, and this is my favorite one, you can refer to it by something called the ICS stop ID, which is used by a separate system called TfL Journey Planner. Now, thank you very much, I'll be here all week. Now, the ICS stop code, which is used by this separate system called TfL Journey Planner, I've searched and searched and searched for hours on end, and nobody can even tell me what ICS stands for. That being said, NAPTAN is one of several standards that exist when it comes to talking about physical spaces for transport in the UK. And that's good because we have a data set upon which to build, but it's also bad because standards are standard. They won't exactly fit your use case, and so you'll need to make some adjustments. Remember those modes we mentioned earlier, so bus and tram and tube and DLR and so on and so forth? TfL seems to refer to the place where two or more modes intersect as a hub, but hubs or transport interchanges aren't actually included in the NAPTAN specification. So TfL's built on top of an already existing spec, which gives us a new standard that's completely undocumented. To be clear, it's not a bad thing to have an abstraction like that. It can be useful, but it's frustrating that it isn't documented clearly. We don't have a clear definition of a hub or any idea of its schema. And as a quick aside, having multiple IDs for the same thing is a pain, but also finding IDs on a thing can also be a pain. If we just take a look at this image, this is a real image by a real transport authority telling us how to find the number on a bus stop. This is not a shitpost. I'd like to draw your attention to the fact that the correct ID has been circled twice on this incredibly washed out image. There's a grainy diagram of a bus stop on the right side, and it also gives us unnecessary information, including the fact that it won the won an award from the Royal Fine Art Commission, and on the bottom there are sort of just crosses through two things which are most definitely not IDs, and it's weird. The last stop we come to is inconsistent and overly complex payloads created by bad API design, and you'll see what I mean in a second. Creating a system that disseminates transport data in real time is difficult. It's inherently complex. You're pulling together data from systems that are tens of years old and that have been created by different companies and run with different operators, and that's fine. Anything I tried to build would probably keel over and die in 15 minutes. But some of the responses that this API returns are painful. We get back deeply nested objects and objects in the same array with different schema that are completely undocumented. You can see I'm losing my mind at this point. And these data structures are intricate and complex and require significant effort to parse and interpret with lots of trial and error. We could fix this with another version of the API. But the API isn't versioned. You create a unified API and you have no way to respond to changing transport and a growing city by other than tacking an endpoint onto an already badly documented API. You release an API and you don't even version it, and it hasn't been versioned since 2015. It's insane. Anyways. How do we actually get past that and build this human consumable API? The first thing is that every good pet project needs a name. And so I thought, after 30 seconds of Googling, I found the perfect domain, tfl.fyi. TFL for your information, which is currently broken. It broke last night, I'm struggling to fix it, but hey ho. Let's talk about architecture and how it's built. JavaScript is normally single-threaded, and it has a runtime model based on an event loop. So it executes the code, it collects and processes events, and then it executes queued subtasks and on. Thank you very much, MDN. If I want to periodically fetch data in the background, using something like set timeout, for instance, then I risk blocking our single thread if a request takes too long or something goes wrong or if I haven't coded defensively enough. And so what we can do is we can use Node's worker threads. We can continue fresh transport data in the background and then perform some pre-processing to make them request ready. And then we can keep all payloads small with only relevant information to allow requests to be served as quickly as possible. The best thing about this is spawned worker threads have their own event loops. So worker threads, although they aren't true threads as they operate within an isolated instance of a V8 runtime, they can communicate by passing messages between one another. And so you effectively can have two Node.js event loops doing two separate things at the same time. This isn't the fake multi-threading that promises give us. This is in fact real, genuine, actual, surprisingly multi-threaded JavaScript. And it works well. In the context of TFL FYI, our main thread, and this is actually the most fun bit, I've put together this diagram, it's great. The context of TFL FYI, our main thread starts by spawning a worker. Every 30 seconds, what we can do is we can fetch new transport data in the worker thread, and then whenever this worker receives this new data, it pre-processes it into request objects. And then what we can do is we can pass these objects to the main thread in a message. We're able to then respond to requests with that new information. We also define a health endpoint on our main thread so that we can make sure that there's data in the system. And all the while, when we're requesting and making requests and pre-processing these responses from this TFL API, we can still respond to these requests with stale data. Nothing stops. The part in the red here operates completely independently from the part in the blue. Having a separate worker thread allows us to have separate code, which makes it a little bit easier to understand. It allows our main thread to keep serving requests while we're off fetching new data. And by moving network and CPU-intensive requests to a separate worker thread, we don't risk blocking our main thread at all. We're able to build out and make the pre-processing more CPU-intense without actually slowing down our main thread. I encourage you to experiment with worker threads because they are pretty cool. Now that we've got the architecture down, how do we actually design our surface or API surface? Well, we can provide endpoints for things which are tangible and concepts which TfL has already communicated well. So lines and bus routes and so on and so forth. And we can also, users can access endpoints to get information about these specific routes and schedules and buses coming and other useful data. When it comes to the real world, our end user doesn't really care about transport hubs or stop points. Thank you very much, I'll be here all week. Transport hubs and stop points or any of those concepts. And so we shouldn't make an effort to communicate that to them. They just want to know what's leaving and from where. And so instead of drawing a distinction between the different types of stops for different types of mode, what we can simply do is search for a stop point using free text. We can fuzzy match the search term, so if a user messes up typing, it'll still match the closest result. And the more specific a search term, the more specific the results will be. If we say Paddington, it will give us the Paddington hub, hate that term, which involves buses, the Elizabeth line, tube, and so on and so forth, National Rail. And if we type in Paddington Rail Station, we get back National Rail results. If we type in Paddington Underground Station, we get back tube results. What have I learned from this? Well, first off, working with other people's APIs is a fucking pain. Mine, of course, are perfect. It's just other people's APIs that are crap. Thank you. When working with TfL's API, I sort of found myself thinking, how could I write documentation to make this easier? And in short, it's difficult. Some of it's down to the fact that I'm not a transport expert. In fact, there is an entire website dedicated to defining niche transport terms. But regardless of the industry, the nuances of mental models and the reasons behind them are difficult to communicate through documentation. So if you've got a concept that's difficult to communicate, consider whether it's worth communicating at all. Does your user need to know the nitty-gritty of your technical implementation? Second, always version your APIs. Please, for the love of God, if you create a new API in the year of our Lord 2023, and you don't version it, I will find you and I will make you pay. Always version your APIs. As an application grows and develops, its customers and their needs will also evolve. So API versioning allows you to use a singular backend and singular backend logic to serve requests for the same customers. Everyone makes mistakes, and it's all about how we plan to fix them. So versioning gives us an important tool in our toolbox to change behavior, adjust behavior, respond to fussy clients, or fix all fuck-ups. Just a general tip when it comes to data structures, put a UUID on it, timestamp it, and always version it. It will save your life. The last bit is consider the context of your customers when building APIs. That does seem obvious, but the biggest lesson I've learned is that creating a good API involves not only considering all users, but the context in which they operate. And it requires a deep understanding of how their needs will evolve over time. It's important to design HTTP APIs to be flexible and extensible enough to accommodate change. And last but not least, I wanted to end this talk on something a little bit deep. So humans are the ultimate consumers of APIs. I have no clue what that means. Whether implementing, extending, or interacting, people will always consume APIs. So let's make it a little bit friendly for them. Next time you're in London, try using TfL FYI when it's, or .FYI, forgive me, when it's working, to check your train, and of course, mind the gap between the train and the platform. I'd like to thank Dylan for inviting me. I'd like to thank Alexander Firmston for proofreading the script, David to DHD for his timer idea. I've been Leo Rivera. You've been listening to me rant about APIs for the past 25 minutes and 5 seconds. Thank you very much. Enjoy the rest of Half Stack and enjoy your break. Thank you.